Okay, 8.3, solving rational equations. Okay, basically we're going to be solving fractional equations is what it comes down to. All right, solving fractional equations, solving rational equations. I'm going to teach you two ways to do it. Okay, the first way I'm going to teach you is kind of a way that is probably logical, makes sense, okay, as to why it works or how it works. Second way, a little bit more of a trick in a sense. I don't want to necessarily call it a trick because it's still right mathematically and it works every time. The second way is a little bit quicker, okay? But I just don't want you automatically going straight to, oh, I got to memorize this trick or this method, okay? I want something to make sense first, but you can decide which one you want to do after you see a couple of examples, okay? A lot of you will probably choose the second one. Okay? All right, so I'm going to start off very, very basic here to give you a general idea. This is a rational equation. This is a rational equation because you have ratios in your equation. Okay, you have fractions in your equation. All right, this is a very, very simple one. This would be an equation that I would ask you to be able to solve for x. 4 over 7 plus x over 7 equals 9 over 7. What is my answer for x going to be? 5, okay? Most of you realize that either because 4 sevenths plus 5 sevenths equals 9 sevenths, okay? Or did any of you just think 4 plus 5 equals 9? Okay? And that's good, okay, because that's actually kind of where I'm going with this here. If all of the denominators are the same. If all of the denominators are the same, could I really then just write the numerator part and solve that? Would that work? Would that get me my right answer? Yeah, it would. Okay? So that's the first method that I'm going to show you. Okay? The first method I'm going to show you is to let's make all of the denominators become the same thing and then just flat out ignore the denominator. Flat out ignore the denominator, write the numerator, and then solve. Minus 4, so you get x equals 5. Okay? That's kind of our first approach that we're going to take, okay, when we get some of these rational equations. We're going to make all the denominators become the same thing, then we're just going to ignore the denominator, and then solve that remaining equation. Okay? Logical? Make sense?
Yes.
Okay? So, we'll do one here. 7 over 2 plus 3 over x equals 3. 7 over 2 plus 3 over x equals 3. What do you think we should make all of the denominators become? 2x. That'd be fairly easy to do. Yeah. 2x would be our least common denominator, if you want to call it that. Okay? Alright, sounds good to me. When you got a whole number, put it over 1. That'll help you a little bit. Okay? So we're going to make all of the denominators become 2x. Alright? So, Cookie, what do I need to do to this fraction?
Put an x.
Multiply by x over x. Alright? Connor, what do I need to do to this fraction? Multiply by 2 over 2. And then, John, what do I need to do to this fraction? What do I want my denominator to become? So right now it's 1, so what do I need to multiply 1 by to make it become 2x?
2x.
2x, right? So multiply by 2x over 2x. Okay, I'm making all of the denominators become 2x. So that gives me 7x over 2x plus 6 over 2x equals 6x over 2x. So we made all the denominators become the same thing, and now we're just going to flat out ignore the denominators because we don't need them. They're all the same. Okay, they're all the same. So therefore, 7x plus 6 has to equal 6x. That's an easy equation now. Just get x by itself. Nice linear equation. Subtract 7x from both sides, so 6 equals negative 1x. Divide by negative 1, you get x equals negative 6. Okay? Questions, thoughts, comments on seeing that type of problem? Fairly low level one, okay, but I wanted to hit that one just to start. We'll keep moving up a little bit as far as difficulty. But questions on that? As always, I would, anytime you're solving an equation, guys, I'd take, on a test for sure, I'd take that answer, substitute it in to make sure it works. Okay, 3 divided by negative 6 is negative 1/2, so I got 7 halves plus negative 1/2. What's 7 halves plus negative 1/2? 6 halves, or 3, so it worked. Okay? All right. Alright, this one's a little bit tougher. 1 minus 8 over x minus 5 is equal to 3 over x. Alright, so we're going to take the same approach here in just a second. Real quick though, what values of x can definitely not be solutions?
5 and 0.
5 and 0. Why?
Because it makes the denominator.
Makes the denominator equal 0. Can you have a denominator of 0? Is that defined? No, that's an error. So I know for sure that 5 is not an answer, because 5 minus 5 would give me a 0 in the denominator. And I also know that 0 is not an answer, because 3 divided by 0 is undefined. That'd be an error message. Okay? So if you would work through one of these problems and you get maybe, let's say for this one, let's say we get x equals 5, you'd actually have to say no solution. Because if you try to plug 5 back in, it won't work, because 5 minus 5 is 0 and 8 divided by 0 is undefined, so it's not really a solution. So just be careful about that. That happens maybe on 1 or 2 of your problems in your practice, okay? All right, anyway, what are we going to make all of the denominators become in this problem?
X squared minus 5x.
How are you going to make this become x minus 5, and you can't tell me to subtract 5 from it? Subtracting doesn't work in fractions. You can't just subtract
You
something.
can do x and then x minus 5.
It's got to be this. It's got to be x parentheses x minus 5. Okay, you need both of those. All right. So you'll have to multiply this fraction by the x minus 5 part. Okay. You can't just have x minus 5, because there's no way to make this become x minus 5. You can't subtract something from the bottom or the top of a fraction. If you do that, that's changing the fraction. You can always multiply it by something. If you multiply the top and the bottom, the ratio stays the same. So, everybody okay with this being our common denominator? X times x minus 5? Okay? All right. So, I'll think of this one as 1 over 1. All right, 1 over 1. So I need all of the denominators to become x times x minus 5. So what am I going to have to multiply this fraction by?
X
Minus 5. I need both of them, right? X minus 5. What do I need to multiply this fraction by? Just the x, right? X over x. And what do I need to multiply this fraction by?
X minus 5.
X minus 5. Okay? So 1 times x minus 5. Let's just do that in our heads. That's not too bad. What's 1 times x minus 5 going to equal? Distribute it out. X squared minus 5x. do I get here then?
Eight X.
8x, right? And what do I get here? 3x minus 15. Okay? So now we've made all of the denominators become the same thing. So now we can just
Ignore the
forget about them, ignore them, get rid of it. Just look at the top, right? Okay? So x squared minus 5x minus 8x equals 3x minus 15. That's a simple quadratic equation. How do we solve quadratic equations? Hopefully we can factor them, right? In order to factor it though, we got to first set it equal to
0.
0. Okay? So which side of the equal sign do you think we're going to move everything to?
Left.
Yep. Let's get it over here.
Left.
So x squared, I'm going to do, so minus 5x minus 8x, that'd be minus 13x, but then I'm going to subtract 3x from both sides, so that's going to give me minus 16x. Because I already had negative 13x, I'd be subtracting 3 more from that negative 13, so negative 16x, and then I'd have to add 15 to both sides. So plus 15 equals 0. That's factorable. What multiplies to 15 and adds to negative 16?
Negative 15 and negative 1.
Negative 15 and negative 1. So therefore x equals 15 and x equals 1. Test both answers. Okay? Plug 15 in, see if it works. Plug 1 in, see if it works. I'll save you the time for right now for class purposes. They do both work, so in this case, both answers are acceptable. Okay?
12. Or about 13.